In this video, we are going to be looking at the basic algebra skills that are needed for this unit of work. So first of all, before we even start that, we're going to look at negative numbers, and in particular, first of all, multiplication and division. And you should know the golden rules really already is that if you have two negative signs together, like in that case there, then they're going to multiply to make a positive number. So minus 6 times minus 5 is positive 30, and also minus 4 divided by minus 2, this one is going to be positive 2. If you have one negative multiplied by a positive, then you're going to get a negative number. So 3 times minus 4 is minus 12, 9 times minus 11 is minus 99, and minus 21 divided by 7 is going to be minus 3. So two negatives will make a positive, but one negative divided by a positive will make a negative. Now, more importantly, we're going to now look at addition and subtraction, and I suggest you think of the following. First of all, visualize the number line. The first number is in the question is where you start on the number line, and then you're going to move up and down depending on the question. So let's have a look how that will work. So first of all, minus 3 plus 5. So the first thing we are doing is we are starting at minus 3 on the number line and moving up 5 positions. 1, 2, 3, 4, 5. And so you can see clearly the answer is 2. If you start at minus 1, and you can see in the second question we're going to go down 4 places. 1, 2, 3, 4. The answer is minus 5. In section C, if we start at 3, we're going to go down 7 places. 1, 2, 3, 4, 5, 6, 7. Our answer is minus 4. And in part D, if we start here at minus 4 and move up 2 positions, 1, 2, you can see that the answer is negative 2. So the same rules that we used in multiplication and division don't work here. You need to visualize the number line at all times. Now if we go on to some slightly more challenging questions, first of all, E, minus 2 plus 7 is going to start there and move up 1, 2, 3, 4, 5, 6, 7. So the answer to that one is 5. Now this one's a little bit more difficult. We're still going to start at minus 3, but we need to make a decision. Are you going to move up or down? And if you have two negative signs next to each other, they sort of cancel each other out and you're going to move up. So we're going to move forwards or up 2 positions, 1, 2. So the solution to this question is minus 1. And even though two negatives did mean move up, the answer is still negative here. It didn't move up enough. In G, we have a start position of minus 1, and if you have one negative sign and a positive sign, we're still moving down. Plus minus 7 is the same thing as subtracting 7. So we're going to move down 7 places, 1, 2, 3, 4. Well, there's a few more places to move. You should work out that you're going to end up at minus 8. Finally, we can't use the number line for this last one because it's a little bit big, so try to visualize it in your head. If you start at minus 25, are we going to move up or down? Well, we're going to move down in this case. So if we start at minus 25 and move down, another 10 places will be at minus 35, so 11 places will be down at minus 36, and that's the correct answer for that question. Now we're going to move on to the algebra. So first of all, adding and subtracting letters, and this is really a question of simplifying your answer. So x plus x plus x is 3x's. So that's all we have to write. The answer there is 3x. Now this one's a little bit more complicated. A plus A plus A, well that bit there is definitely worth 3a. But if you look, we've got a minus A, a minus A, and a minus A. Well, they're going to cancel out those original A's and leave us with nothing. So the answer is just what's left over there. The answer is an A. Now, you might want to write 1A, and 1A is fine, but the best way of writing that is just to leave it as an A on its own. Let's have a look at this one. The next one, b plus b plus b, so that's 3 b's in a row, but we're going to take off 2 of them to leave us with just 1b. But just like in the previous question, that isn't the correct way to leave your answer. You want to leave that just as b. Finally, we've got a positive s there and a positive s there, so that's 2 s's, but we're going to take off these 2 to leave us with nothing. We've still got that left over, minus s, so that is the correct answer. And the final question on this page, we've got a positive t and a positive t, but we're subtracting 2, so what you're left with is 0. Now you shouldn't write 0t, it's just 0 as your final answer. Now on to this second type of algebraic addition, where you've already got 4a or 5a, a certain amount of a's, and you're adding those up. Well, this works just like normal addition. 4a plus 5a plus 2a is going to be 11a. 4a, take away 7a is minus 3a, and take away another 8a is minus 11a. Now, when you've got a's and b's going on and the terms are different, you can only collect up the a's together separately to the b's. So if we focus first of all on just the a's, well, 5a take away 6a is minus a. Now then we focus on the b's. If I have a 2b, take away a 12b, I'm going to end up with minus 10b. Now, the last couple of questions look very complicated, but they are just the same principle. Start off by looking at the a's, do those, and then look at the b's. So, we're going to have a 12a, take away an 11a, so that's going to leave us with 1a, plus 53a is going to be 54a. Now, the b's, we're going to have 9b and 4b, which makes 13b, and we've got to take away 42b. So really what you're doing is 13 take away 42, and if you work that out, you're going to have minus 29b. Final question, you've got a's, b's and c's, so work them out separately. Starting with the a's, 2a minus 11a is going to be minus 9a. Then the b's, we've got 2b and we've got 9b, that makes 11b, but take away that 11b, we'll cancel out all those b's, so we don't have any at all. Minus 4c plus a 5c is a positive c, just one of them. So the answer is minus 9a plus c. Now, in these following questions, we've got a combination of things going on, but if they're not identical terms, then they're not going to collect up together. So, for example, in the first question, we've only got a 4x and a 14x that can be collected together. So we've got 18x, and the x squareds are totally distinct and separate in the collection process. We've got a 2x squared, take away 3x squared, so that's a minus 1x squared, or minus x squared. In the second example, we've got a 3a and a minus 15a, so overall there we've got minus 12a. We've just got the minus 2b, so we can't add anything to that at all. Now we've got 12ab and we've got minus 15ba. Now an AB and a BA are identical, so we can collect these up. So if we've got 12 of them, take away 15 of them, we're left with minus 3 of them, so minus 3ab. And you would want to write it in alphabetical order, A followed by B. Finally, there's a plus 12 left on its own, so we can write that on its own just like that. I won't do the final question, see if you can do it for yourself. Okay, the final part of this lesson is on multiplying letters. You need to be careful that you are totally comfortable with the difference between multiplying and adding. People can get very confused between the two. So a times a times a means a cubed. B times b times b times b times b is b to the power of 5. So that power, or that index, is the number of times you're timesing it by itself. A times b times c can simply be written as ABC. Now, in the final question, you count up the number of A's timesing together. That's going to be A cubed, and then you times that by the number of B's adding together, which of course is 2, so it's B squared. In these types of questions, do the numbers separately first and then do each of the letters. So 2 times 4 is 8. A times A is A squared. So the answer is 8A squared. 4 times 3 is 12. A on its own, well, that's just an A, and B on its own is just a B. So the answer is 12AB. 5 times 4 times 3 is 60. A times A is A squared. And that B is there, so it's 60A squared B. 7 times 2 times 3 is 42. And then you've got B times B, which is B squared. Final question, 2 times 3 is 6, times 2 is 12, times 2 again is 24, times 3 again after that is 72, times 10 is 720. And then count up the A's. We've got A times A times A in there, so A cubed, and B times B in there, which is B squared. Last type of question, bringing it all together, we've got 2 times 3, which is 6, A times A in the first A squared, and another A times A in the second A squared, so that's 4 A's timesing together, so we've got A to the power of 4. 4 times 3 is 12. We've still got the A to the 5. We've still got the B squared. So we can just simplify and leave it like that. Third question. Again, do the numbers first. 3 times 4 times 2. Well, that's going to be 24. Then start with the A's. We've just got an A squared. We've got a B and a B squared. Now, if you think about it, you're going to have B cubed overall in that situation, so your final answer there is 24A squared B cubed. Next question, we've just got the 2, there's no other numbers multiplying that at all, so we'll just leave the 2 at the front, and then if we go through, well, A squared times A cubed is A to the power of 5. We've got B, that's B to the power of 1, times B to the power of 5, which is B to the power of 6. And final question, 7 times 3 is 21. A cubed times A to the 6 is A to the 9. And B to the 4 times B to the 8 is B to the 12. And you should notice the pattern throughout that when you're getting 2 indices and you're timesing them together, you can just add the powers. Right, that's all you need to access the first lesson. Good luck!